You probably walk past your washing machine without a second thought, but inside that white metal box in your laundry room sits a highly specialized robot waiting to activate on your command. To see how it actually manages to scrub away tough stains, we need to bypass the outer shell and look at the hardware hidden inside. Look at this exploded view of the machine's anatomy. Inside are 13 distinct components. It's a chaotic puzzle, but we can organize them into systems. The outer shell, electronic brains up top, the stomach, muscles down below, balancing shocks, and plumbing. Every load of laundry relies on this entire team of hidden parts communicating and moving in perfect sync. Let's start with the perimeter. The outer casing and transparent front door with its rubber seal create a watertight vault to keep your laundry room dry. Up top, selecting wash settings on the digital control panel means you're interacting with the machine's brain. That electronic control board right behind the panel translates your button presses into specific electrical signals. It acts as the central processor, telling the rest of the machine exactly what to do and when to do it. Directly below those electronics are the two main washing chambers, where the actual physical and chemical cleaning happens. They work together, but perform different jobs. The large gray outer tub is completely sealed to hold a deep pool of water and soap. Inside of that is the inner rotating drum, which holds your actual clothes. Notice that the inner drum is made of stainless steel and covered in tiny perforations. Those tiny holes let the soapy water flow freely in and out, while keeping all of your fabric safely trapped inside. But a smart processor and a watertight bucket lack the physical power to actually scrub dirt out of your clothes. That physical force comes from the heavy mechanical drivers anchored beneath the tub. Down here, we have the electric motor and the drive belt and pulley system. The electric motor generates the raw rotational force. That power travels through the thick rubber drive belt, forcing the inner drum and all your heavy, wet clothes to tumble. Spinning 80 pounds of wet laundry at high speeds creates a massive amount of kinetic energy and violent shaking. To keep the machine from tearing itself apart, the central tub sits on heavy-duty shock absorbers and hangs from thick suspension springs. These balancers isolate the violent movement inside the tub, preventing those vibrations from traveling to the outer casing. Meanwhile, to manage the water inlet valve regulates the fresh supply, while the water pump and drain pipe connection handle the dirty outflow. Alongside is a coiled heating element, warming incoming water to activate your laundry detergent's chemical reactions. The electronic board gives the orders, but these heavy motors, springs, and plumbing pipes supply the raw physical force and fluid control to carry them out. Now, let's put all of those mechanical pieces back together into one unit and see how they initiate a full wash cycle. First is the fill phase. The central brain signals the inlet valve to open, fresh water pours into the tub, and the heating element activates to warm the pool. Next is the agitation phase. The electric motor drives the belt, tumbling the inner drum back and forth to drag the clothes through the warm, soapy water. Once the dirt is lifted, the drain phase begins. The pump turns on, forcefully evacuating the murky water out through the ribbed pipe. Then comes the climax of the cycle, the high-speed spin. This process relies on centrifugal force. Centrifugal force is the apparent outward push on a mass when it is rotated. As the drum hits top speed, this force pins your clothes against the outer walls and drives the remaining water out through the perforations. During this intense rotation, those thick suspension springs we saw earlier are stretching and compressing at maximum capacity to keep the machine grounded. Finally, the motor spins down, the door seal unlocks, and your clean, damp clothes are ready to be removed. Getting a clean shirt requires precise sequential timing between digital logic, managed fluid dynamics, and serious mechanical power.